We've looked at the graphs of both sine and cosine, and now we're going to use some of the knowledge we have about those graphs and those functions to look at graphs of tangent, cotangent, secant, and cosecant. As we begin here with tangent, remember that tangent is sine over cosine. And remember that we know the period of tangent is equal to pi. Because tangent is the relationship between two functions being divided by each other, anywhere that the cosine of x is 0, this function is going to have a vertical asymptote. We know that the cosine of 0 is equal to 0 at pi over 2, 3 pi over 2, negative pi over 2. It rotates around. And so as you can see here, that's where these vertical asymptotes come into play. But also notice the key part here that it passes through the point 0, 0. Because when x is 0, the sine of x is 0 and the cosine is 1, meaning that the point is going to be 0 here. Cotangent, in contrast, is going to not exist anywhere that the sine is equal to 0. It also will have a period of pi. And then these vertical asymptotes are now going to occur at 0, pi, and 2 over pi. And notice how this changes the look of the graph as well. As you move, you need to be able to recognize those two basic forms of both tangent and cotangent. Secant and cosecant, we can make some similar comparisons here. We know that secant is the inverse of cosine. So anywhere cosine is 0, we're going to have those vertical asymptotes. But also note that it's going to, the function of secant is going to tend toward either infinity or negative infinity, depending on if cosine is positive or negative. And again, notice that cosine here goes through the point 0, 1. When x is 0, we know that 1 divided by 1 is 1, and then it reaches infinity in either direction. Cosecant is going to have those asymptotes again where sine is 0, and we see that 1 over sine. Notice how this shifts off of that point of 0. What I want to do now is I want to show you how these ideas apply in terms of the homework, because the questions work a little bit differently. So let's look here at some examples of the homework. Share a different screen with you. So for example, what you'll need to do on the homework is you're going to show, first of all, you have to be able to recognize the initial graph. For example, in this one, we're looking at a function of cotangent. So we know in this case that cotangent does not pass through the point 0, 0. We know it's going to be one of these two based on the graphs that we just looked at. We've got our sine and cosine, secant and cosecant. So our cotangent graph is going to look something like this. The next thing you have to be able to do, though, is apply the concept of transformation of functions that we learned back in Pre-Calc 1 to make these determinations. So for example here, if there is a negative out front, that's going to indicate an x-axis reflection. Since there's no negative out front here, it's not going to reflect across the x-axis. A vertical shift will also have something outside the function added or subtracted. So there is no vertical shift for this cotangent graph. A phase shift, remember from when we talked about sine and cosine, occurs inside the parentheses there. So there's no phase shift. There is going to be a vertical stretch, and that comes from the 3 halves that's out front. And then last but not least, that horizontal shift comes from this b value that's in front here. And to figure out the period, remember we take the period of the original function, which is that pi value, and we divide it by b. So we're going to have pi divided by pi in this case, which gives us the period of 1. Let's look at a similar one that deals with something like this, with tangent. Again, here we've got sine and cosine. We know it's going to be between these two, so we know tangent goes through that point 0, 0. Again, the parts to look for, there's no negative here, so there's no x-axis reflection. This +3 is what gives us a vertical shift up. So that's going to move the graph up. Again, there's nothing in here that's going to give it a horizontal shift. There is going to be a stretch or compression because of the 1/2 out front. And last but not least, there's nothing here in front of the x, so there is going to be no shift in the period. Last but not least, let's skip to one. Here's one that deals with secant. We know from our previous note that the secant graph was the one that went through 0, 1 is our most basic function. And then our shifts that occur, we have a negative in front here, which causes a reflection. We have a vertical shift down due to this -2. And notice I just put in a 2 because I've already indicated it's down with the negative. It is going to have a horizontal shift of pi/2, and it's going to go to the right by, let me get my keypad here, by pi/2. And then it is going to have a vertical stretch or compression due to the 2 out front. And then last but not least, there is no b value here, so the period will not change. Hopefully that's going to help you get started with that homework. If you have further questions, please feel free to reach out.